Okay, welcome back, everyone. One program we started a couple years ago is a fellows program where we bring in bright aspiring students and give them tough problems, and they surprise us with their clever solutions to these interesting work. Kashika is one of our former fellow alumni, I guess, and she's going to present the work that she did last summer, again about keeping an eye on users' jobs and their data.
Okay. Hi. Everyone. My name is Kashika. I'm an undergrad here at UW-Madison, and as Greg mentioned, I was a fellow last summer, and I continued as an intern for fall and spring to bring my project to completion. So the project I worked on was a toolkit for profiling HTCondor workload. So basically going from how to understand our jobs from per job data to an aggregated workload insight. So the problem that we wanted to solve was that researchers want to know how their workload is doing without having to dig for the details, which means that when you get this huge amount of verbose data about your jobs from HTC, you don't want to go through each and every parameter, each and every job and do it 10 times over. And instead, you just want to know whether it's a thumbs up or a thumbs down kind of situation for your cluster. So the objective of this project is to make a tool or set of tools that give researchers simple feedback. And the way that most people value receiving feedback is through these three main branches. And that is what we have tried to include in our project here. First is visual, so through the means of bar graphs, um, plots and stuff like that. And then we have processes, which is just quantifying processes and data. And the final is evaluator, which is taking in the information, all the data, and then looking how that is actually performing from an insight of something that the facilitation team can provide you or the CHTC team can provide you. So through focus groups and through talking to researchers during my time last summer, we came to finalize that these are the main things that researchers want to know about their workload. Primarily, the first being the status of their jobs. When you have 10,000 jobs in a cluster, you kind of want to know, okay, how many of these jobs are running, how many of them are on hold, how many of them are just sitting idle. And sometimes because that information can be a little scattered across the system, we want to have one place where everything is available. And then time. My jobs are completed and they ran for a couple of weeks, but what was the actual scale of time, run times that my jobs and specifically my workload took? Resources. I requested these resources and my jobs were scheduled based on said request of resources, but how much of that did I end up actually using? And then jobs on hold. That is a recurring thing that we hear from researchers using our services, is that the whole system is kind of hard to interpret, especially someone who might not have a very technical background, and especially for people who are working with large clusters. And then to sum it all up, how is my workload doing? So we are providing this information through these 4 small tools and then one giant encompassing tool. We have a dashboard, runtime visualizations, resource utilization report, and then a whole classifier. And to sum it all up, a cluster health report. I will go into each one of them in depth following. But this is kind of how the flow of things look right now. You give it a cluster ID, and then the program will take it through the data layer. We have provided an option for you to save that data in the form of a CSV file. The specifics of that are not yet set and will come up to as the dev team and the facilitation team finalize on the project. But having a CSV per cluster is important, because if the information is removed from, let's say, the Condor queue or Condor history, because it's an old cluster, but you still want to have records of it, it is important that you can access that information even like months down the line. And then we have one main CLI router, which you can use to access each of the specific tools, and all of them will feed data into the main program. So this is how the cluster dashboard looks. We have the cluster ID, and then we have bar graphs for presenting the status of each of the jobs accumulated for each of those status, so like idle, running, removing, completed, etc. We have the counts and also the percentage. The idea of this is that you don't have to pull data from both the queue and the history or anywhere else, and you can just have one small tool to kind of tell you on large what are my jobs doing. And it's also good because it's again a visual representation. So, and it's also giving you some precise counts and measurements so that if you want to store this data, it's good for you. And then we have the runtime visualization. So we have options of viewing your runtimes in two ways. One, we have this scatter plot, and then the cumulative distribution form, and then we have one, the histogram. So again, good thing about visual feedback is that you're able to observe trends much quicker, and you're also able to decipher information from them much easily without having to compute it separately through your own scripts. And this also helps in kind of having some uniformity about going to facilitation team for any kind of problem you might be facing with your clusters. So this is how the runtime thing looks enlarged, because I know that which was very small. But so it will have the cluster ID, the number of jobs, and you're also able to see 50% of the jobs got done before 21 hours, and so on and so forth. And you can also see like a lot of the jobs are taking like around 1 day. So it's giving you a visual feedback, and you're able to see what the distribution of it is looking. And in the other histogram, we are able to see this is what a healthy cluster looks like. Jobs are pretty evenly distributed, and there are no jobs that are running less than 10 minutes. And you're again able to see how much of a time variation there is. There are some jobs who are getting done within like 14 hours, and some are taking 4 days. So it's again giving you a distribution of how your cluster is kind of expanding in time. This is how I would say like a not a bad cluster, but something which might be going wrong in a cluster might look like, because we have a lot of these jobs which are in red, and they're signifying that there is something wrong because they're getting finished before 10 minutes of runtime. So again, like trying to kind of get you feedback which might not come intuitively, but might come from information that the facilitation team might have. Then we have the hold classifier. I have a bigger image of the hold classifier to show how it looks finally. But what it basically is that it is a bucketing system for all the held jobs. And it gives a tabular summary, which includes not just the hold reason, but also the subcode, the average time on hold, how many jobs are on hold for this kind of hold reason, and also what is an example reason of it. So this is how it looks like. I hope it is readable. And it also gives a legend about what subcodes are actually meaning, what the code is and what this label actually means. So first we have how we are grouping them. So the big buckets are whole reason and whole reason code, whole reason label, and then the subcode. And then they're grouped by this, and you get the number of held jobs by this. But there is another level of bucketing, which is the example reason. So we do fuzzy matching by the string to further divide these hold reasons into smaller groups based on the first line of the error message or the held message that we get from the system, so that if there is any kind of pattern or any kind of like changes in two jobs with the same hold reason code but different error messages, you're able to see. And this just goes to show that we're trying to more diversify the classification and give you more insight into why your jobs are being held. And then we have a legend. So this is also useful for information keeping, and also if you're going to the facilitation team, like, hey, I keep running into code 12, and it's this, and I know the reason is this, but why? So it's good for keeping track and not just troubleshooting it once and then coming back again running the same issue. And the benefits of this is this is a much easier to understand summary. It's more concise than having to read all the things for a job, especially if you have a huge number of jobs in a cluster. It can make it hard to kind of see to each whole message. And this way it gives you a summary of what is actually happening. And it's also adaptive to the changes in the system, because the bucketing system happens from the information being presented by the job and by the whole reason code. It does not particularly matter if things change in the future. What will need changing is the legend, but again, because pulls information from a table, it can adapt to system changes, and it can be there for you to use in the future as well through future code releases. The next we have is a resource utilization report. It's a long report, so I will again break it down into specific things. But basically, it will give us a comprehensive report of the things that we have requested and how we actually ended up using it. And this is again useful if you feel like you are not requesting enough resources, or you think you're requesting too many resources. And again, requesting too many resources will again make it harder for your jobs to get scheduled on the system. So this is also to see where am I lying when I'm come to requesting and actually using them. And again, the benefits are it aggregates data from all the jobs, and you can use it to get insight of how to make better utilization. First off, we just have a small summary of what the cluster ID is, what the summary is, what did you actually end up requesting, and how many jobs you requested it for. And then we have the number summary table, so which will just give you the stats about what was the medium, what was the quantiles, and what if my utilization is like very off the top, or is it very like scattered. As we can see, it is the case in CPU. A lot of these are like 2%, but then we have the max being like 4,000%. And then we have the distribution. So again, a bar graph, but this is again useful to see if most of your jobs are using one bucket of utilization, or are they more spread out. Like this distribution. Now this user had requested for 4 GB, but at the most they were using something like less than 2. But memory, they requested 4, and they were using it pretty distributely. So it's again good to see how you're actually, how the jobs are acting about all this. And then we have an optimization recommendation section where they can tell you what is a good kind of metric for you to actually put for your next cluster things if you're running the same set of jobs. And it also gives you a summary of where you can kind of improve. So we can see that disk usage is pretty low and CPU usage is pretty low. And this can be used for not just troubleshooting your whole job. Sometimes jobs are on hold because you requested too less resources, or too low or too high. So it can be used for that. And then to end, we have the final cluster health report, which is basically the first default thing which you can use in our tool. It will give you a summary of what the cluster health is looking like based on these 6 aspects. So zooming into that, we have memory efficiency, disk efficiency, CPU, health jobs, fast jobs, runtime consistency, and job status. So we can see that the overall status of it is critical, which is not to say that your cluster will not run at all or it's going to break, but it's just to show that there is some issue with it and there can be room for improvement with it. And because we are still working on getting this tool out to you guys, the tool for details will get updated with the actual script that you can just copy and paste into your terminal to look more into the specific issue. And the next steps for this project is to make it ready for you all to use. And then based on the feedback that you all provide to us, we will fix any issues or make any improvements or anything like that. If you guys have any feedback about this or any recommendations, or you guys think that this could be an interesting use case or can be an interesting addition to this toolkit, I'll be happy to know. Thank you all for having me.
Thank you. Any questions for Kashika? Oh, sorry, you're not off the hook yet.
So I had one specific question for the buckets in the resource report. Are those static, or do you adjust them depending on how much the user requested or the jobs used?
Those are static, based upon the information that is provided us by the Condor history, by basically the Python bindings. So it does not build upon the data of previous runs of the cluster, but I think that's a really good suggestion, and we can look into kind of making sure that things are getting built upon for future.
Yeah. And then I had a second, more general question. What's something interesting you learned in this process of writing this code and developing the tool?
I think the biggest learning for me was that systems aren't perfect and people aren't as well, because I think that is a given when it comes to like working with such a huge system such as like CHTC and Condor, is that there are going to be issues and people will run into issues even if they do something perfectly. And it's always important to kind of make sure that you know how to solve the problem rather than not having problems at all.
Ken and then Kurt.
How challenging is it to get that CSV from OS Pool, AdStash, or from the Condor history? And then how big does that end up being, like, per job?
So the CSV is stored for like the whole cluster, not just for each job. And we have the script right now pulls data from mainly from the Condor like Python bindings, but there is also an option to pull data from the Elasticsearch. So it's thought that it is a time consuming process, especially if it is an older cluster or it is a bigger cluster. And that is why we kind of have this thing in the thing where it will tell you at each 1,000 jobs that is completed this many jobs, so that user knows that it's still running. But that definitely it is a point of concern about how long can this process going to take, and we're trying to work with the dev team to make sure it's as seamless and as quick as possible.
Thank you, Kurt.
Thanks for a nice talk. I really appreciate the statistics. For the resource, as the only one where you didn't have a real visualization, I suggest a what's called a box and whisker plot, which is particularly helpful for non-Gaussian statistics, which is certainly the case. But building on Christina's question, is there any feedback for the user at an individual level about over provisioning? I mean, if we under provision, the job doesn't get matched. But if we over provision, we have to wait longer. Is there a way to teach us about that?
So I I don't think I'm qualified to answer this as a measly undergrad, but I think like any kind of questions, I think the facilitation team is like very apt to answer that. But from what I've learned and seeing clusters is that this kind of like thing it's a little bit trial and error, just because the way that sometimes you cannot anticipate how jobs behave. And I've noticed this a lot with people who are working with like large clusters, is that they might not have a thing. So I think it's more of a trial and error thing, and that is why having this kind of report is useful, is because you can actually see what's happening and then build upon that. I hope that answers your question.
Okay, I think we have a question from Zoom, and then Dan. in the back.
This is a question from me, not the Zoom. I'm a big fan of those terminal user interfaces, all the graphs and charts and stuff. Is that all bespoke code to generate those, or is there like a library framework that you're using?
I'm sorry, I didn't understand the question.
So is there like a library or a framework you're using to generate all those charts, or is that all bespoke code, like custom generated?
It is just code because we wanted to integrate it as part of the actual Condor package. We tried not to use any external libraries as much as possible, and we also wanted to make sure that outputs are in ASCII, so that there's no issue of being able to see images and stuff, and the output is uniform throughout. So it's all using just code, not using any external libraries.
Thank you.
That was a great talk, Kashika. I'm wondering how you're envisioning users interacting with this tool. I think that's estimating your resource requirement is probably one of the hardest things a researcher can do. And so I'm thinking this might be an amazing tool for folks that are saying, hey, I'm not sure what this program really uses. I'm a biologist. I don't want to think about cores. Are you envisioning them using it as like almost a testing tool at first before submitting, let's say, 1 million jobs to the cluster?
Yes, absolutely. And also it's, I think, a good tool for researchers who kind of want to get feedback about their clusters quick and on their own. And that was the main essence of this project. And also a big shout out to the facilitation team, Andrew and Ian, who were mentors to me in this project, and all the CHTC people who supported me through this project. And the idea was that it kind of makes it easier for the researchers but also the facilitation staff to give feedback, so that there's a little uniformity, and for the user so that they can also get feedback on their own, and they also feel more confident experimenting with the system.
So just a comment on what is cooking. it's great that we can get this information out of history, but we feel that it may be too late, and it would be useful for the access point itself, namely the SCAD, to know some of this information rather than doing it as a postmortem. So we are slowly adding means for the SCAD to collect information about the user, about a collection of jobs, so that can be used almost in real time to make decisions. So we are definitely interested in listening and hearing and suggestions of how this can work. It's great to do it post-mortem, but can we do it also in terms of the actual managing of the jobs?
Thank you. If there's no more questions, let's give a big round of applause to our brave fellow.